Alright, today we're going to talk about the first part of section 5.5 from Algebra 2, long division of polynomials. So we're only going to talk about long division in this part. So really what we're going to do is we're going to first compare traditional long division to long division of polynomials and then learn how to divide polynomials. So what we have to do is we have to go back to what, 3rd or 4th grade when you guys learned how to long divide. So remember, when you long divide, you have to look at each piece. So what I mean by that is I need to look, if I'm dividing 743, dividing it by 3, remember we have to look, how many 3's can I put into 7? Well, I can put 2 of those into there. So 3 times 2 is 6. Subtract that from there, we get 1. Pull down our 4. How many 3's go into 14? Well, we have 4 that go in there. 3 times 4 is 12. Subtract there, we're left with a 2. Bring down our 3. Now we have 23. How many 3's go into 23? We have 7. 7 times 3 is 21. Subtract there, and look at that. We have a remainder of 2. Now what we're going to do is we're going to always write these as fractions, our remainders. Remember how to write our remainders as fractions. It's going to be 2 divided by 3 as our fraction. There's our solution. All right, let's try another one quick, remembering how to divide. Going back to our 3rd grade, the way we write this is 20 divided into 2,784. So 2,784 divided by 20. Now we have 2 pieces looking at that. So how many 20's go into 27? 1. So we subtract 20, bring down the 7, bring down the 8. How many go into that? Well, we're left with 3. So we subtract 60. So we're left with 18. Bring down our 4. How many go in there? We're left 9. Subtract 80. We have 4 left. Oh, we have a remainder of 4/20ths, but we can simplify that down. So 4/20ths would actually become 1/5. There's our remainder. Long division using polynomials is almost the same. It's very, very similar. So the way we're going to do this is we're going to rewrite this. We're going to rewrite it 3x cubed plus 2x squared minus 7x plus 4 divided by, and on the outside, x squared plus 1. Now here's where the trick is. All I have to do is I need to look at that first part, the x squared. What do I need to multiply x squared by to get that first piece there? What do I multiply x squared by to get to 3x cubed? Well, all I need to multiply it by is 3x. So on the top, I'm going to put my 3x. And then I'm going to take that 3x and I'm going to multiply it by each piece. So 3x times x squared is 3x cubed. And 3x times 1 is positive 3x. And I'm actually going to rewrite that positive 3x. I'm going to put it down over here. Now I'm going to put that whole thing in parentheses and subtract, because I'm subtracting that whole piece. Now the reason I need to make sure I put that parentheses around so I know I'm subtracting every single piece. So I'm going to subtract 3x cubed from 3x cubed, and what do I get? Nothing. If I have 2x squared, I'm not subtracting anything down below that one, so I'm just going to bring that down to 2x squared is going to come down. But now we have negative 7x, and we're subtracting a positive 3x, so it's going to be minus 10x. And then I'm going to bring down my positive 4, bring that guy down too with it. Now again, we have to looking at our first piece here, so our x squared, and now we're looking at our first piece over here, our highest coefficient there. So what do I need to multiply x squared by to get to 2x squared? Well, really all I need to multiply that by is a positive 2. So again, we're going to bring it down. We're going to multiply 2 times x squared. Well, that's 2x squared. 2 times 1. Well, that's going to be positive 2. And again, I'm going to put that underneath the piece. Subtract it. So we end up with negative 10x plus 2 left over. So now what do? Just like I had before, I'm going to take my remaining piece and I'm going to put it over a fraction over what I'm dividing by. So it becomes minus 10x plus 2 over x squared plus 1. And what am I going to put in between my 3x plus 2? Well, it's going to be a... All right, let's look at this next problem where we have 4x cubed plus 2x squared minus 7x plus 4 over x squared plus 3x. This is written as a fraction, but remember, what is a fraction representing? It's division. So we're going to divide the top by the bottom. So on the outside of our division symbol is going to go the denominator, and on the inside is going to go the numerator. We're going to put the numerator on the inside. Now, just like before, we're going to look at our leading piece to figure out what we need to divide or multiply by. What do I need to multiply x squared by to get to 4x cubed? 4x. So 4x is what I'm going to multiply each piece by to get 4x cubed plus 12x squared. And I'm going to divide that whole thing, or sorry, I'm going to subtract that whole thing from the top. So we're left with, well, the 4x cubes cancel out. 2x squared minus 12x is going to be negative 10x squared. I'm going to bring down my negative 7x and my positive 4. Now again, we're going to multiply, what do I multiply the x squared by to get to negative 10x? Well, I need to multiply that by, negative 10x squared times negative 10. So again, I multiply each piece over here, so we get negative 10x squared, we get minus 30x, and we're going to subtract that whole thing again. So we're going to do negative 10x squared minus negative 10x squared, those cancel out. Negative 7x minus negative 30x, we're going to get a positive 23x, and we're going to bring down our 4, plus 4. Now I can't do anything else here, because I can't multiply x squared by anything to get to 3x, or 23x, so I'm just going to add, and I'm going to make this a fraction, 23x plus 4 divided by x squared plus 3x. And there's my divided version. There's my solution. Alright, I want you guys to try this one on your own. I'll put up the answer in a second. Alright, and there's my solution for that fully divided polynomial. Alright, I want you guys to try this one on your own now too. Alright, here's the solution I got. I want you guys to focus on one thing though that I did here is right in here. I put a space. And why did I put a space there? I personally put a space there because I didn't have an x for that specific polynomial. And so I didn't want to forget that there was a space there, so when I went and I subtracted that red portion, I didn't do it in the wrong place. So you don't have to do that. I personally chose to do that to keep things in order, in line where they should be. Some teachers have you do it, some teachers don't. I personally do it myself. I don't expect you guys to have to do it either, or have to do it. This is all we're going to talk about in this video, so let me know if you guys have any questions, rewatch anything you need to rewatch. And we'll go on to synthetic division next.